Hello everyone, today in this video we are going to talk about triangle law of vector addition. So after this video you should be able to state the triangle law and apply the triangle law of vector addition. Before starting the video, you can check the comment or description box. If there is any mistake in the video, I will let you know in the description box. So first of all, let's understand why do we need vector law. So if you add 2 plus 2, you'll get 4. Similarly, if you add any scalar quantity like mass, if you add 2 kg and 2 kg, you'll get 4 kg. But when you add 2 Newton and 2 Newton, you may get 0 Newton, 1 Newton, 2 Newton or 4 Newton. So you can get any value between 0 Newton and 4 Newton. So when we give 2 Newton and 2 Newton to an object from opposite side, then we'll get 0 Newton as the resultant. So if 2 Newtons are applied to an object in the same direction, we'll get the resultant of 4 Newton. And if we apply 2 Newton perpendicular to each other, that time we'll get 2.8 Newton as the resultant. So as the vector have direction also, we cannot add them using the simple algebra. So for that we need vector algebra. So we'll understand how to add two vectors which has direction. So now we'll understand triangle law. So triangle law is used to find the resultant of two vectors. Suppose I have a vector A like this, and suppose this is vector B, and suppose these two vectors are making the two sides of the triangle. Then the resultant of these two vector will be given by the third side of the triangle, and this is the triangle law. If two sides of the triangle represent two vectors, then their resultant will be represented by the third side of the triangle. So this is the triangle law. And to apply the triangle law, the tip of one vector and the tail of two vectors should come together. Out here you can see this is vector A and this is vector B, and tip of one vector and toe of another vector is coming together. If they come together, then only we can apply the triangle law. If tip and toe of two vectors are coming together, then the third side of the triangle will represent the resultant, and this tip of resultant and tip of vectors B should come together. So out here you can see tip and tip of vector A and vector B are coming together, so we cannot use triangle law out here. Out here also you can see tail and tail of two vectors are coming together, so out here also we cannot use triangle law because tail and tail are coming together. Here you can see this is vector A and this is vector B, so you have to tell whether we can use triangle law or not. So you can give your answer in comment box. So this is very important. So tip and tail of two vectors should come together, and tip of one vector and tip of the resultant vector should come together. So now we'll derive the triangle law of vector addition. So this is our vector A and this is our vector B, and this is the angle between vector A and vector B. Theta is the angle between two vectors. So according to triangle law, the resultant of this two vector will be given by the third side of the triangle. So this is the resultant. And suppose beta is the angle made by the resultant with one of the vectors. So out here beta is the angle between resultant and vector A. So please don't get confused between theta and beta. Theta is the angle between two vectors which we are adding, and beta is the angle which the resultant is making with one of the vector. Now we will drop one perpendicular from here. Now this side will be b cos theta and this side will be b sin theta, and b is the magnitude of this vector. Without the cap is the magnitude. This is the length of b vector. So now we'll give the names. So this is the diagram for our derivation. So now we'll derive the relation. So we are considering two vector a and b, and the angle between them is theta. So now we'll consider this triangle O and P. So sin theta is Pn by On. Pn is equal to, so I want to find this Pn, this length. So Pn is On sin theta, and On is vector B, So we'll write Pn is equal to b sine theta. So this side is b sine theta. So out here we are using magnitude only, so I'm not writing b cap because we are using the magnitudes only. So similarly cos theta is op by on. So op is equal to, because I want to find this length, so op is equal to on cos theta. Again on is b, so op is b cos theta. So I've already written the values out here, b cos theta and b sine theta. Now we'll find the magnitude of this resultant vector. So we'll use Pythagoras theorem in this triangle m and p. So mn square is mp square plus np square. So our mp is mo plus op, so I'm writing mo plus op instead of mp. So now I'll put the values. So mo means vector a, and op means b cos theta, and pn means b sine theta. So I'm putting the values. So I'm not writing vector a out here because we are finding the magnitude. So now after putting the values, we'll open this bracket, then we'll get this. And if you take this b square common, you will get cos square theta plus sine square theta, and you know cos square theta plus sine square theta is 1. So out here I'm putting 1. Now I'm taking this square this side, so I'm getting a square plus b square plus 2ab cos theta. So out here you can see, to find the resultant we have to consider the angle between them also. So this is the expression for the magnitude of resultant vectors. So using this formula we can find the magnitude of resultant vector. Now we have to find the direction, that is this angle beta. So to find this beta, we are using the triangle m and p again. So tan beta will be given by pn by mp, but mp is mo plus op, so I'm putting mo plus op for mp. So now I'll put the value. So pn means b sine theta, and mo means a, and op means b cos theta. So our beta will be tan inverse of this term. So this is the angle. So we got the magnitude of resultant vector and we got the direction of resultant vector. So using the triangle law we can find both magnitude and the direction of the resultant vector of two vectors. So using the triangle law we can find the magnitude and the direction of resultant vector. Resultant vector means the addition of two vectors. So after adding a and b we are getting the resultant r. So magnitude of the resultant will be given by this expression, and the direction of the resultant will be given by this expression. So to find the direction or angle beta we have to write the vector opposite to the angle out here and out here, and out here we have to write the vector which is opposite to the resultant vector. So out here we have to write b because b is opposite to beta, and resultant is making angle beta with a, so we have to write a out here. If we interchange this a and b, the formula will be something else. So out here you can see I have interchanged a and b. So for this case beta will be tan inverse a sine theta, as I've already told that out here we'll put the vector which is opposite to the angle, and out here we'll write the vector which is making angle with the resultant. So you can see the difference. Out here we have a, so we have to write a out here and out here, and in this case we have beta out here, so we have to write beta out here and out here. So using this method we can find the direction of resultant. Now let's see the special cases. So this expression will give the magnitude of resultant vector. So if a and b are parallel, if vector a and vector b are parallel going in the same direction, so that time theta will be 0 and cos theta will be 1. So that time resultant will be So instead of cos theta I can write 1. So this is a plus b whole square. So I'll find resultant to be a plus b after cancelling this square and root over. So this time if they are in same direction, the resultant will be maximum, and the resultant will be sum of magnitudes of a and b. So out here you can see this black line is the resultant. So after adding this two, we'll get the resultant. And if they are anti-parallel, if a and b are in opposite direction, so that time theta is 180 degree and cos 180 is minus 1. If you put cos theta to be minus 1, then you will get a square plus b square minus 2ab, and this is a minus b whole square. That time if you cancel this 2, you will get resultant to be a minus b, so subtraction of this 2. So this will be minimum. So out here you can see this is the resultant, so subtraction of this 2. So if a and b are perpendicular, if they are like this, so theta will be 90 degree and cos 90 is 0. So your r will be root over a square plus b square. So this will be a resultant. So how to get the resultant? By shifting this vector out here, by making the triangle law. You can see tip and toe, so third side will give the resultant. So you can see if they are parallel or in same direction, the resultant will be maximum, and if they are anti-parallel, if they are going in opposite direction, so the resultant will be minimum, and if it is making 90 degree, it will be somewhere between maximum and minimum. For application of triangle law, please watch this video on my channel.